So this video discusses about the addition, subtraction, and also the multiplication of the Surds. But before we go into the detailed structure about all these, so I want you to understand about the like terms and the unlike terms of a Surds, rather of the Surds. Let's say if we have, and that should be, let's say if we have the nth root, of x, and plus, let's say the nth root of x. Now these actually two terms are said to be the like terms because the roots has the same carrier given as n, and also in the same case we also have the same terms inside the roots. Then these are said to be the like terms, and we can be able to add them or have it as should be 2 nth root of x. And likewise, if we are to subtract, let's say if we are to subtract, so in this case, let's say if we are to subtract, so in this case these are the like terms that we can be able to subtract where it is necessary to. And let's say if we have the nth root of, let's say, x plus, let's say, the mth root of let's say x. Now these terms are unlike terms because they have the roots of different carriers. Here we have the nth root, and this is mth root, so they are different despite that we have the same terms inside, so they are said to be unlike terms. And for instance, we can have, let's say, square root of, and there should be 2, and plus, let's say, the cube root of, let's say, 2. Now these are unlike terms, we cannot be able to add or subtract them, so keep that in mind. So we can only add or subtract the surds that are actually alike in terms of the components inside and also the nature of the root, rather should be the carrier of the root. Now let us see how we can add or subtract the following actually surds. Let's say we have it as, let's say, 2 times the square root of, and that should be 3, and plus 7 times the square root of 3. So how should you have to add the two actual surds? So in this case we have, this is the square root and also this is the square root, and the inner terms are also the same. We have 3 and 3, hence these are the like terms can be added. So in this case we'll have it as 9 times the square root of 3. So that's the principle behind. That's how we can make it up. And let's say if we can have the following, let's say we have the 13 times the square root of 2, and let's say minus 7 times the square root of 2. So how do you think this can be subtracted? So in this case these are the like terms. In this case we'll have it as 5 times the square root of 2, so which is given as that. And let's say if we have, let's say, 12 times the square root of 5, and let's say plus 5 times the square root of 5. So how do you think we can have this? Now all these are the like terms, we can just have to add them. So have it as 17 times the square root of 5. So in case you may need to have an insight on what is happening here, so we have the square root of x and I should say we have the square root of 5 and the square root of 5. These are the actually of which they are the same. So what is the common factor? We have it as the square root of 5. So what we are remaining with is 12 plus 5, and which is the same as square root of 5 like that times, we have it as should be 17. So in this case it means we have it as 17 times square root of 5, so which is the same as that. So keep that in mind. So simply we just have to add or subtract the coefficients there. So that is the principle behind all those things, as you can see. Now let's say if we have a case like 12 times the square root of 7 minus, let's say, square root of 7. So how can we have this? So in this case these are the like terms, so the coefficients will have to subtract. We'll have 11 times the square root of 7, so that is the solution. And also say, let's say if we can have 3 times the square root of, let's say, 11, and plus, let's say, 7 times the square root of 11 minus, let's say, 11 times the square root of 11. And as you can see, all these things are the like terms, therefore just have to add or subtract them. So let's first thing just have to add these two. So in this case we have 10 times the square root of 11 minus 11 times the square root of 11. So in this case we have negative square root of 11, so that is the solution. And what if we can have this? Let's say if we have, if we have 7 times the square root of, let's say, 45, and the minus, let's say, 2 times the square root of 45. So how do you think this can be actually simplified? So in this case all these are the like terms, therefore can be able to subtract. We'll have 5 times the square root of 45, so we'll have that. And what if we can have something like this? Let's say if we have 5 over, let's say, 3, and times the square of, let's say, 54, and the minus, let's say, 1 over 4 times the square of, let's say, 6. So how do you think this can be actually expressed? Now we have the terms of different, actually, by the way, these are actually unlike terms, because what we have inside, they're different. We have 6 and we have 54, but at the lowest actually value is a 6. But isn't it possible to express 54 to have a something, or can't we express 54 to have a something similar to the square of 6? Let's think of this. So in this case we can be able to express 54. In other words, 54, square root of 54 can be reduced to, we'll have 5 over 3 times 9 times 6, minus half, it should be 1 over 4 times the square root of 6, of which 9 is the actually perfect square. We'll have it as 5 over 3 times 3 times the square root of 6, minus 1 over 4 times the square root of 6. Now in this case we'll have this and this one being cancelled. We'll have 5 square root of 6 minus 1 over 4 times the square root of 6. Now these are actually like terms where you can be able to subtract them. So take note of that. Now how about the multiplication of the surds? Now we have the first case on the multiplication, where we have the scalar value, scalar versus surd. Now in this case, if we have, let's say, a, and let's say times the square of, let's say, I should have this, let's say if we have a times the nth root of, let's say, x, this is the same as a times nth root of, so this is the same as a times the nth root of x. So which means if we have, let's say, 2 times, let's say, square root of 5, this is the same as 2 times square root of 5. We'll have this. And where we also have the another case, surd and versus another side. So how should you have this on the side versus the another side? So on the side versus the another side, here is the something you should have to understand. If we have, let's say, nth root of, let's say, x and times the nth root of, let's say, m, this is the same as the nth root of xm, and this is happening because the roots are the same. So in that case, we'll have to multiply the terms inside and covered by the given root. So which means if we have, let's say, the square root of 5 times the square root of, let's say, 6, this is the same as the square root of 5 times 6. That is the same as the square root of 30. That is according to the principle behind. And likewise, if it happens that the roots are different, let's say if it happens to have it as, let's say, if we have, let's say, the nth root of, let's say, x times the, let's say, mth root of, let's say, n. So in this case, let me just have it as mth root of, let's say, y. So as you can see here, the roots are different. So in this case, we'll have it as, nth root of x, times the mth root of y, because they are different. We cannot combine them like that. So take note of that. And finally, we also have the another principle you should have to understand on the multiplication of the surds. And what is that principle? If we have a minus, let's say, b, and the times, let's say, m plus, let's say, x. So how do we multiply these, or how do we expand the product of these two expressions? So in this case, we have it as a times m, which is am, and a times x, which is ax, and minus minus b times m, that is negative bm, and minus b times x, that is negative bx. So this is also another very important aspect that is being used in the multiplication of the surds. And also another thing you have to understand is, if we have, let's say, a plus b, let's say, to the power 2, this is the same as having it as a plus b, times c, a plus b. You should keep this in mind. So let us see how we can have to, multiply the following surds, and simplify where it is necessary to. Let's say we have the product of 7 and 3. So in this case, since the roots are the same, it means we'll have the square of 7 times 3, which is the same as the square of 21. And let's say if we have 6 times the square of, let's say, 5, the times, let's say, 2 over 3 times the square of 7. So in this case, the roots are the same. Now this is the same as having it as. Now in this case, the coefficients also have to multiply. So we'll have it as 6 times 2 over 3, and it times 5 times should be 7, which is the same as, that should be 3 into 6, which is given as 2, and 2 times 2 we have it as 4, and 4 times, that is 45. Should be 35, not 45. We'll have it as 35. So that is the solution. So the coefficients multiplies themselves. Let's say if we have 5 times the square of 3, and let's say times 7 times the square root of 11. Now since the roots are the same, it means we have, the coefficients of multiply. We have 35 times the square root of 3 times 11, which is given as 35 times 33. We have that. And how about, let's say, if we can have something like this. Let's say we have the square root of 3 to the power, let's say 6. So how do you think this one can be expressed as? So in this case, this is the same as having it as the square root of 3, times the square root of 3 times the square root of 3 times the square root of 3, and you are actually up to 6 times. So have 1 2 3 4 times the square root of 3 and also times the square root of 3. So in that case, it means since the roots are the same, it means we have the square root of, now have 3 to the power 6. So what is the 3 to the power 6? So try to express that on the calculator. And how about if we have, let's say, 4 square root of, that should be 3 to the power, let's say, 3. This is the same as having it as 4. This is the same as 4 to the power 3, and it times square root of 3 to the power 3. So another principle that you should have to understand is this as well, before I forget. So if we have, let's say, a times the nth root of, let's say, x in the overall to the power m. Now this is the same as a to the power m times the nth root of x to the power m. It is the same as that. So it's just have to use that one. So in that case, it means we'll have it as, what is 4 to the power 3? So what is 4 to the power 3? We have it as 81. Should be 64 rather. Should be 64. We have it as 64. And that times we have the square of, and that should be 9. What is the square of 9? Because we'll have it as 3 to the power 3. That should be 27, not 9. So we have it as 64 times the square of 27, which is the same as, 27 can be actually simplified further. That is 64 times the square of, 3 times 9, which is the same as 64 times, what is a square of 9? We have it as 3 times square of 3. Then I will have to multiply this. And also let's think about this one, how we can also make it up. Let's say if we can have 5 square of x, let's say, to the power 2, and that times, let's say, have 2 square of x, and say to the power 3. Now how should you have this? So in this case, this is the same as having it as 5 to the power 2 and times the square of x to the power 2. It is the same as that. And the times, we have 2 to the power 3 and it times the square of x to the power 3. It is the same as that. Now we'll have it as 25. What is the square of x squared? We have it as x. And the times, we have it as 8. And what is the cube of x squared? It should be square of x cube. It is the same as, just have it as, x squared times x. That is, if we want to simplify that on further. So have it as 25. 25 times x times 8. Now this is the same as having it as x times the square of x. So we can multiply this and having that one as well. So be careful with the concept of the Surds. But before you go for this, make sure that you have gone through the video we discussed about how to simplify the Surds. So you come across it in the actually just have to come across it, on my video playlist. You access all these things on the YouTube channel, TikTok, Instagram, and sort of. You come across all these things. They are there. Let's say if we have the square of 3 and a plus 4 and the over to the power 2. So how should you have this? Mind you, this is the same as having it as the square of x. It should be square of 3 plus 4 times c, square of 3, plus 4. So in this case, we'll have it as what is x to the power, actually should be cubed of, actually square of x times, I should say, what is the square of 3 and also square of 3? And we have it as the square of, it should be 9. And the plus c, we have the square of 3 times 4, we have it as 4 times the square of 3. We have plus c, 4 times the square of 3. And a plus 16, like that. So in that case, what is the square of 3? Actually, a 9 we have it as 3. And the plus, if these are like terms, we'll have it as 8, square of 3, and a plus 16. So these things are actually, these are like terms. So what is 3 plus 16? We have it as 19 plus 8, square of 3. So that is the solution. And how do you think you can have this? So feel free and pause the video and try to express that, then compare. Square of, let's say, 5 minus 3 and the over to the power 2. In this case, this is the same as having it as the square of 5 minus 3 times c, square of 5 minus 3, like that. So in this case, this is the same as having it as, square of 5 times 5 is square of 5, which is the same as square of 25. And the minus 3 times the square of 5, and the minus 3 times the square of 5, and plus should be 9. So what is the square of 25? That is 5. And these are like terms, so have negative, that is 6. Negative 6 times square of 5 plus 9. So these are the like terms, so have to add, that will be given as 14, minus 6 times the square of 5. So that is the solution. How about, let's say, if we have this case as well. Let's say if we can have something like this. We have 2, times the square of 5 minus, let's say, 3 times the square of 3. And say times 2 times the square of 5. And let's say plus 3 times the square of 3. So how do you think you can have this? So principle remains the same. We'll have this and times this. So the coefficients will multiply. We have it as 4 times. What is the square of 5 times square of 5? That is the square of 25. Then we have this times this. The coefficients will multiply. We'll have positive 6 times. Now have 5 times 3. That is 15. And the minus. And also the coefficients will multiply. We'll have negative 6. Square of should be 15. And the coefficients will multiply as well. We'll have should be negative 9 times the square of, that should be 9. So what is the square of 25? That is 5 and times 4, that is 20. And the plus, by the way, these are like terms, and they'll go as well. And what is the square of 9? That is 3. 3 times negative 9, that is negative 27. So which is the same as 20 minus 27. That is the same as negative 7. So that is the solution. So try to have the following at your own time and appreciate whether you are good at that or not. So let's say have the square of should be 5 minus 6 to the power 2. And also try this. We have, let's say, square root of 75 minus, let's say, square root of 120, in order to the power 2. And let's say have the square root of 48 minus the square root of, let's say, 5, in terms square root of 2 minus, let's say, 7. And also let's say we have the square root of, and that should be 48, plus the square root of 12 times the square root of 48, and minus should be plus square root of 108. So how do you think we can have this? So try to express this at your own time. Thank you.